today we're going to talk about a couple of different things. First, we're going to deal with temperature conversions. So you should be able to convert from Celsius to Fahrenheit, Fahrenheit to Celsius, and we're even going to throw in Kelvin also. So you will do those conversions. We're going to talk a little bit about accuracy and precision. Are they the same? Are they different? By the time you're done today, you should be able to tell me. Third thing we're going to do is I'm going to give you an equation for percent air. It is an equation that you'll do on the first lab, and we will use that equation throughout the entire year to tell us, okay, how good were we at obtaining the desirable results? Okay, how accurate were we? So let's go ahead and get started and talk about the temperature scale. Now, we discussed a little bit yesterday, or previously, I don't know whether it was yesterday or not, but we discussed previously that there is a Fahrenheit scale, there's a Celsius scale, and there's a Kelvin scale. All right? Fahrenheit, Celsius, and Kelvin. Well, Anders Celsius is the gentleman that we attribute the Celsius scale to. Lord Kelvin, William Thomson, came up with the Kelvin scale. Now, people in my other class earlier asked me, well, what about Fahrenheit? Is there some guy named Fahrenheit? I don't know that. I don't know that for sure. But you know what? We're going to find out because I'm going to Google it right now. So yes, Daniel Fahrenheit. So I guess maybe I should redo this slide and put a picture of old Fahrenheit on here too. Maybe I did it this way. One, because like I said, I didn't look up where Fahrenheit came from. Probably two, because what are the metric system ones we use? Is it Fahrenheit? No, we use Celsius, we use Kelvin. Now, let's look at the different temperature scales. And you can see up here, we've got boiling point, freezing point of water. On the Fahrenheit scale, anybody know what water boils at in Fahrenheit? Jacob? 212. Okay? 212. Freezes at 32. So in between the boiling and freezing point is 180 degrees Fahrenheit. The Celsius scale boils at 100 degrees Celsius, freezes at 0 degrees Celsius. The Kelvin scale boils at 273 Kelvin, boils at 373 Kelvin, freezes at 273 Kelvin. So right below it says notice. Notice that 1 Kelvin is equal to 1 degree Celsius. A Kelvin is equal to 1 degree Celsius. Something just to make a mental note of too, folks, is that when we talk about Fahrenheit and Celsius, we use degree. So if we talk about the freezing point of water, it's 32 degrees Fahrenheit, 0 degrees Celsius. But when we talk about Kelvin, do we use degrees? No. Okay? So it is 273 Kelvin. So when we talk about the Kelvin scale, we don't use degrees with it. Calculations using temperature. Calculations using temperature. Generally, when we're doing mathematical calculations with temperature, we use Kelvin. How do you calculate Kelvin? You take the degrees Celsius and you add 273.15. So Celsius plus 273 equals Kelvin. Kelvin minus 273.15 equals Celsius. So we can convert back and forth with Kelvin and Celsius by either adding or subtracting 273.15. Here's an example. Our body temperature is around 37 degrees Celsius. So if we add 273, and I should have put 273.15, if we add 273.15, we are going to get 310.15 Kelvin. Liquid nitrogen. Liquid nitrogen is negative 196 degrees Celsius. If I convert that to Kelvin, it is going to come out to 77 Kelvin. I would use 273.15. All right. Now, the thing about the Kelvin scale that I haven't mentioned yet, and why we use it in mathematics, is because the Kelvin scale does not have any negative numbers.
Ron,
Yeah,
right here, you have Logie Kaiser.
absolutely do.
Could you send me to the office for a moment, please?
Sure can.
Thank you.
So getting back onto that, the Kelvin scale does not have negative numbers. So the lowest that you can possibly get Kelvin is 0. Okay? The lowest that the Kelvin scale will go is 0. And at 0 Kelvin, there is no movement of any molecules. Therefore, there is 0 temperature. Absolute 0. Yep, that is 0 Kelvin. So what would it be Celsius? Absolute 0. Tyler? Negative 273.15. All right. Here is the Fahrenheit formula. Okay? The important thing is what is in the box. Oops. What is in the box right here. So if I'm taking notes here, I write Fahrenheit formula, and then I write that in the box. Because that is how we convert from Fahrenheit, or from Celsius to Fahrenheit. So let's just say we've got these up here. Okay, we'll just use these as an example. We'll use one of these as an example. If I have 1 degree Celsius, okay, 1 degree Celsius, that's not going to draw very good. 9 fifths times 1 plus 32. is what I am going to do mathematically. So, when I do that calculation, I take 9 divided by 5, and I get 1.8. Times 1 is 1.8. Well, what's 1.8 plus 32? 33.8 degrees Fahrenheit. Okay? 33.8 degrees Fahrenheit. Now, the Celsius formula. Once again, I'm not so concerned with anything but what's in this box right here. What's in this box right here will help you convert from Fahrenheit to Celsius. So get that equation down in your notes. Now, the thing about this conversion, okay, the thing about this conversion and where people go wrong with it is they don't follow the order of operations. I was always taught, please excuse my dear Aunt Sally, for the order of operations, which is parentheses, exponents, multiplication, division, addition, subtraction, right? Please excuse my dear Aunt Sally. So following that, I look at that equation, I see please, I see parentheses. So I've got to do that first. Where the error comes is when people program the stuff in their calculator without using parentheses. The order of operations without using parentheses makes it different. And I'm going to show you. Okay, I'm going to show you the different ways. Now, we just did 33.8, and we know that's 1 degree Celsius, right? So let's do 33.8. So, parentheses, 33.8 minus 32, in parentheses, and multiply that by 5/9. When I do my math, 33.8 minus 32, I get 1.8, and I multiply that by 5/9, and I get 1, which I should get. Now, how you can do that in your calculator, I put parentheses 33.8 minus 32 in the parentheses, times it by 5, divide it by 9, and I get 1. Now, don't put the parentheses in there and see what happens, okay? So, the second one is 33.8 minus 32 times 5/9. Put that in your calculator and see what you get, okay? Put that in your calculator and see what you get. When I did that, I got 16.02 repeating. Is that what you got? Now, why are they different? Okay, this one right here, this bottom one right here, they are multiplying 5/9 by 32 first. And then they take that number and subtract it from 33.8 because there's no parentheses that says order of operations. So this right here is not what you want to do. You need to get the order of operations. Excuse me. You want to get the order of operations up here. The please excuse my dear Aunt Sally. So make sure that when you're doing the Fahrenheit to Celsius, you include the parentheses in there. Now here's a temperature conversion. It says a person with hypothermia has a body temperature of 29.1 degrees Celsius. What is that in Fahrenheit? Well, you take 9/5, which is 1.8, multiply that by 22.9, and add 32 to it. So you should get 52.4 plus 32. A person with hypothermia has a temperature of 84.4 degrees Fahrenheit. Now, what's our normal body temperature? 98.6 degrees Fahrenheit. So hypothermia is meaning that is lower. That is lower than our normal temperature. Here's a learning check. I'm going to give you a second to do it. Go ahead and convert this, and we'll see which the answer is, 1, 2, or 3. When you did it, what'd you get? Number 1, number 2, number 3. You should have got number 3, 41 degrees Celsius. A pizza is baked at 455 degrees Fahrenheit. What is that temperature in Celsius? What'd you get for that one? 1, 2, or 3? 2. 235. 235. Now let's do a little bit of accuracy versus precision. Accuracy versus precision. Accuracy versus precision. Accuracy is the degree to which the result of a measurement, calculation, or specification conforms to the correct value or a standard. Precision is marked by exactness and accuracy of expression and detail. Well, that really, I get accuracy. That precision kind of gets a little confusing for me. So, what I've done here is I've used the target here. And we're going to explain accuracy and precision with this target. Okay? Now, my first target, I shoot 3 arrows. Boom, boom, boom. All 3 of them hit the bullseye right there. So were they accurate? Yes, they hit the bullseye. They were very accurate. Were they precise? Yes, they're all 3 grouped together. So my precision is good. My grouping is good. They are precise. My accuracy is good because they hit the bull. My next target. Oop, that one's a little off. Oop, that one's a little off. Okay? Are they accurate? No, they're not near the bull, are they? Are they precise? Yes, I grouped them pretty good. I just couldn't hit the bull.
So you're saying precision is affected by accuracy?
The precision is just saying, okay, can I recreate that to be that same value over and over and over and over again. Okay? But the accuracy is it right? Okay? Now look at this next one. This next one. Boom. Well, there's a scud. There's another one. Okay. Are those accurate? No. Are they precise? No, they're not grouped. Okay? So, looking at these, the top or the very left one is both accurate and precise. The middle one is precise, but it's not accurate. The third one is neither accurate nor is it precise. Okay? So that is accuracy and precision. You're going to need that for a lab coming up here, as well as this equation right here. Okay? This equation right here. So go ahead and write this down, and we'll discuss this in a second. Now, the percent error allows us to see how close we are to the accepted value. Okay? So, the observed value, the value that you got in your experiment, minus the accepted value, what you should have got if you did everything totally correct, divided by the accepted value times 100. Now, I want you to notice something right here. These things right here. What are those things? Absolute value. This is calculated, people, in both ways. Some people use absolute value, some do not. When you use WebAssign, you should use absolute value. Okay? Because WebAssign uses absolute value. I typically do not use absolute value. And I'll tell you why. If I get a plus or I get a minus, it tells me whether I was above the accepted value or below the accepted value. And it allows me to try to help determine where my error was. So if I get a negative number, looking at that, that tells me that my observed value was less than the accepted value because I got a negative number. If I get a positive number, it tells me that the observed value was higher than the accepted value. So that's why when I use it, I don't use absolute value. I use the pluses and minuses. Now, you're going to run into many different people, and they all might have different ideas. Okay, you might get to college, and they say, yeah, use the absolute value. All right? But right here, I'm telling you, when you use WebAssign, use the absolute value. Okay, because they'll count it wrong if you have negative numbers. Okay? But I like to have those negative numbers and that positive number so that I can determine, hey, was I above or below the accepted value? All right? So that's why I personally do not use the the absolute value.